Welcome to part 3, Predict Deaths Using Case Fatality Ratio. Thus far, the bulk of our work has centered around cases and how to predict cases. In this section, we're going to talk about a method to predict deaths using the case fatality ratio, which is the fraction of cases resulting in deaths. So you may be wondering why we aren't using the same procedure to model deaths as we did for cases. And the reason for that is that we have some underlying information that's very important, and we know that deaths lag cases by 2 to 3 weeks. So this is a property of the coronavirus, is that cases come first and then deaths follow, and there seems to be some lag by 2 to 3 weeks. So since we know what cases were 2 to 3 weeks ago, we can make a prediction for the current number of deaths by using this case fatality ratio. So as a concrete example, let's say that there were 1,000 cases 3 weeks ago, and the case fatality ratio, which is abbreviated CFR, the CFR is, say, 1% in a particular area. We would multiply this 1% times the 1,000 to get an estimate of 10 for the number of deaths for the current day. So the solution that we will implement is going to be in this function over here, calculate CFR. We're going to assume a 15-day lag between cases and deaths. We're then going to find the number of cases between 15 and 45 days prior. So there'll be a 30-day window here. We're going to total up those number of cases. We're going to do the same thing for deaths, but use the window between 0 and 30 days prior. So we'll have these two windows and totals for each deaths and cases. We'll then divide the number of deaths by the number of cases to calculate the CFR. Okay, so let's look at this function over here that has been created. So it takes in the data, which is the dictionary of 4 data frames that we've used before, and the last date. So the last date we want to build our model on, or really just make the calculation on. So this is the last date that we're seeing actual data. So the first day of deaths will be 30 days prior, so we'll just subtract 30 days. The last day of cases will be 15 days prior, so we'll go between 15 and 45 days ago. And then we'll take the first day of cases, will just be 30 days prior to that. So we have 4 dates here. The last date, which is really the last day of deaths. The first day of deaths is 30 days prior. The last day of cases is 15 days prior. And then the first day of cases is 45 days prior. So there we have our definitions. And what we're going to do is, for each of the groups, so there's just those two groups, the USA and world, we're going to calculate CFR for every area just by using normal vectorized data frame operations. So we'll get the data in cases, so we'll get those as, these are data frames. We're just simply selecting them from the dictionary of data frames. We're then going to select the, since this is cumulative data, we'll just subtract the last date for the deaths minus the first date from the deaths. So we'll get the total number of deaths for that window. We're going to do the same thing over here for cases. So these are cumulative, so it already gives us the total. We don't even have to sum it up. Then we'll just simply divide the deaths by the cases to calculate a CFR, and any areas that do not have a CFR, we'll just give it a some default value of 0.5%. Okay, so let's go ahead and do this. We're going to calculate all of them. We'll just say for November 5th is our last date. And we're going to pass in this last date over here. We're going to give the data. This is just the original data of those 4, the dictionary of 4 data frames. So we calculated our CFR. And so for the CFR will be now be a dictionary of just for each group. So it'll just be world and USA. So here's the CFR for the first 10 countries. And here's and it's actually just going to be a series, right? So the CFR will just be a series of data here. And then for the USA, we have the CFR for different states. Okay, so this is our function that we are going to use in order to calculate the CFR, which will eventually be used to make predictions.